right, first of all, on number 8, I would like you to change the y equals 2 to y equals 0. So the problem will work out the way I want it to. All right, find the volume of the solid formed by revolving the region bounded by the graphs of y equals negative x plus 2, y equals 0, and x equals 0 about the y-axis. So let's draw a picture. This is a non-calculator problem, so we got to graph it without our calculator. This will be a line. The y-intercept is 2. The slope is -1, so I'm going to go down 1 over 1, down 1 over 1. So I've got my line, and then you'll notice x equals 0, x equals 0 is a boundary, and y equals 0 is a boundary. So this is the area in question, and this time we're going to revolve it about the y-axis. If I'm revolving it about the y-axis, since it's vertical, we are going to be using the shell method on this one. So I'm going to have volume equals 2 pi. It's going to go from an x value of 0 to an x value of 2 because that's where it's hitting the x-axis. And then my radius will just be x. And then when I do top minus bottom, it's going to be negative x plus 2 is the top, minus 0 is the bottom. And I don't get to use my calculator on this one, so I'm going to go ahead and distribute that. So I'm going to get 2 pi integral from 0 to 2, negative x squared plus 2x. And obviously when I distribute x to the 0, it's just 0. And then from here, I'm going to go ahead and take the integral of that. This is going to be negative 1/3 x cubed plus x squared. I'm going to evaluate it at 0 and 2. If I plug 2 in, 2 cubed is 8 times negative 1/3 is negative 8/3. And then plus, when I plug 2 in there, 2 squared is 4. And then minus, if I plug 0 into both of those parts, I'm going to get 0. Please keep in mind this whole thing still needs multiplied by 2 pi, so I'm going to get 2 pi. I'm going to get a common denominator, which will be negative 8/3 plus 12/3. So that will give me 2 pi times 4/3. So that final answer will be 8/3 pi as my volume. All right, problem 9. Find the volume of the solid formed by revolving the region bounded by the graphs of y equals 6 minus 2x minus x squared and y equals x plus 6 about the x-axis. All right, this one we probably would need the help of our calculator a little bit to get this one. We're going to go ahead, we'll have a parabola that looks something like that, and then we'll also have the line x plus 6, which is going to look something like that. And so we will be looking for this region right here. Okay, since we're going about the x-axis, notice we're going to use washer or shell. That will definitely create a hole. So we will be using the washer method on this one. Okay, this is a non-calculator section, so to get these points of intersection, I'm actually going to have to find the point of intersection without my calculator, so I'd like to show my work. I will find out where 6 minus 2x minus x squared equals x plus 6. So if I move everything over to the left side, I'll subtract x from both sides, and I'll subtract 6 from both sides. I will end up getting negative 3x minus x squared is equal to 0. I'm going to factor out a negative x, and so that will give me 3 plus x. And so the two places where they're going to intersect is x equals 0 and x equals negative 3. And you'll notice that looks about right, but that means that when I graphed it, I definitely did not graph it right. This should be over there. Whoopsie whoops. All right, so now I'm ready to do the volume. I'm going to go from, if I'm using the washer method, a pi goes on the outside, they intersect at negative 3, and then once again at 0. And then I'm going to do the top, the outer radius squared, because this is going to make the outer part of the shape. So that's going to be 6 minus 2x minus x squared. So it's the outer radius squared minus the inner radius. The inside of the shape will be the x plus 6, and that will also be squared. And then dx. And now from here we get to do some fun foiling. So we're going to go from pi negative 3 to 0. Okay, if I FOIL 6 minus 2x minus x squared, I will get 36 minus 24x minus 8x squared plus 4x cubed plus x to the 4th. And then I'm going to subtract x plus 6 squared, and if I FOIL that, I will get x squared plus 12x plus 36. All right, so then from here, if I combine like terms, I should end up getting negative 36x minus 9x squared plus 4x cubed plus x to the 4th. Okay, I have not taken the integral yet. So now I'm ready to take the integral. When I take the integral of that, I'm going to get negative 18x squared minus 3x cubed plus x to the 4th plus 1/5 x to the 5th. There's still a pi attached, of course, and I'm going to evaluate it at negative 3 and 0. All right, so we've got a pi still hanging on there. When I plug in 0, fortunately for all of those, I just get 0. And then minus, when I plug in negative 3, negative 3 squared times negative 18 is going to be a negative 162. And then when I plug in negative 3 in there, I'm going to get plus 81. And then when I plug in negative 3 to the x to the 4th, I'll also get plus 81. And then when I plug in negative 3 to the 5th, I'll get negative 243 fifths. All right, just to save me some time of getting a common denominator, I notice that negative 162 plus 81, that all cancels out and gives me 0. And then minus negative 243 fifths will give me positive 243 fifths pi. So that will be my volume. All right, problem 10. Find the volume of the solid formed by revolving the region bounded by the graphs of y equals 2x squared, y equals 0, and x equals 2 about the x-axis. So we've got y equals 2x squared, which is a parabola. We've got y equals 0, which is just the x-axis, and we've got x equals 2. So we've got that. So this is the shape we're looking at right here. If I'm revolving it about the x-axis, it's just going to have no gaps or holes, so we get to use the disk method on this one. So I'm going to have volume equals pi. I'm going to go from an x value of 0 to an x value of 2. And then the top is going to be 2x squared. And the bottom will be 0, and it is the radius squared. So this one was a little bit more friendly. All right, so we get volume equals pi. And then if I do 2, the minus 0 obviously doesn't count. 2x squared squared is going to be 4x to the 4th. And then when I take the integral of that, I'll get 4/5 x to the 5th. Obviously, I still have my pi there. I'm going to evaluate it at 0 and 2. If I plug in 2, I will get 2 to the 5th, which I do believe is 32 times 4 is 128 fifths, minus, if I plug in 0, I'll get 0. And that still is being multiplied by pi. So when I multiply that out, my volume will equal 128 fifths pi. Number 11, the base of a solid S is the region enclosed by the graph of y equals x cubed, x equals 4, and the x-axis. If the cross-sections of S perpendicular to the x-axis are squares, then find the volume of S. Okay, the first thing that I'd like to do again is draw a picture. We've got y equals x cubed, which is going to look like this. We've got x equals 4, which goes this way, and then we have the x-axis, which goes this way. So this is my region in question. And I'm going to be using cross-sections, so I know that the volume using cross-sections is just an integral from a to b, and it will just be the area of those cross-sections. So the first thing that I'm going to do is go ahead and do a little side trip to find the area of my cross-section. The area of my cross-section, since I have squares, will be side squares. And since I'm perpendicular to the x-axis, I'm going up and down, so it's going to be, to get the side, I'll do top minus bottom. So this will be top, which is x cubed, minus the bottom, which is 0 squared, and that will simplify into x to the 6th. So I know my area is 6, so my volume is going to equal an x value to an x value. It will go from 0 to 4, and then my area is x to the 6th dx. From here, I'm going to go ahead and take the integral. The integral of x to the 6th will be 1/7 x to the 7th. I'll get to evaluate it at 4 and 0. So first of all, I get to do 4 to the 7th power. Aren't you glad this is a non-calculator problem? Which means that's 4 times 4 times 4 times 4 times 4 times 4 times 4. And if I do that, I'll get 116,384 sevenths. And then minus, if I plug 0 in, I'll get 0. So my volume will be 16,384 sevenths.